Hi. In this final section on an introduction to artisanal and small-scale mining, we're going to look at gold. Now, gold is important to me because I used to be a gold prospector and miner in Alaska. There's a picture of me pouring out grains of gold from a Nalgene water bottle, which is how most placer or alluvial gold miners in Alaska transport and store their gold. And yeah, the image on the top right shows what a typical small placer mine looks like, with just a few pieces of heavy equipment, maybe a bulldozer um, for clearing overburden and pushing up pay gravel, an excavator to feed the wash plant, which is a trommel which is rotating and with high pressure water bars to spray the gravel that contains the gold in between the sand and clay, pebble matrix, and a front end loader to clear the tailings at the end. And yeah, there's an image of me doing some grade control and looking at an area which was mined underground, historically within frozen gravel, which we were expanding to remine using larger and bigger equipment. And this is a very typical look at a small scale mechanized mine. Um, there are several hundred of these that operate in Alaska, in the Yukon and BC, in Canada, as well as in New Zealand. So the artisanal small-scale gold mining sector is really significant. Produces around 15 or up to 20% of the world's gold production, and employs 15 to 20 million direct workers. And what is also notable is that artisanal miners around the world, in most poor parts of Africa and Asia, use mercury. And because of this, so much mercury is used by the ASGM sector. It's the largest emitter of mercury in the world. Mine production is shown on this image here that displays kind of just how significant but also hidden ASM is. So that large yellow block represents the annual gold production by all the world's mines, about 3,300 tons. And if you look at the gold production from a few big countries that produce, such as Colombia or Zimbabwe or Sudan, um, those are represented by those hashed purple darker blocks. And another significant supply of gold comes from the recycle gold sector, about 1,000 tons a year. And mercury, as I said, these images come from Zimbabwe, and they show how mercury is used. So mercury is a neurotoxin that affects the central nervous system and can have both acute, severe, and chronic effects on health. But first kind of signs of mercury poisoning, which can lead to Minamata disease, are trouble with vision, or jitters with fingers, loss of sensation, slurring of words, and eventually further musculoskeletal problems occur around kind of losing balance and concentration. And it can eventually lead to longer term deformities and all sorts of neurological problems. The mercury being poured in the top left there is in liquid state. So mercury is unique in that it's a liquid metal at room temperature, and it amalgamates, it combines with the gold particles to form a mercury gold mixture, which can then be refined using a low temperature heat. The bottom right there, the young man's using a blowtorch, but the men in the top right are just using some charcoal, very low temperature, and because of the low vaporization temperature of mercury, even at room temperature, mercury vaporizes and is released into the atmosphere. But add a little bit of heat, and that burning, that vaporization occurs much quicker. So using mercury the miners are able to extract even smaller specks, particles of gold. Um, and so, of course, it's been in use for thousands of years um, because it's known to recover more gold and therefore earn more money. And the miners add mercury oftentimes directly into the milling circuit, either within a ball milling process, or the women on the bottom left there are milling by hand using a stone and just grinding kind of sand-sized particles down to silt and clay-sized particles, which will then be amalgamated with the mercury. And so when mercury is added directly into the milling process, huge quantities of mercury are used and lost to the environment and have really severe health impacts. Globally, mercury is equivalent to hepatitis B or Parkinson's disease in terms of the health impact measured by the number of years lost or disabled meant to people. So this just summarizes those points again. Mercury has been used by ASGM for hundreds of years, and this process I told of adding it directly into the milling cycle is called whole ore amalgamation and results in really significant losses. The vapors, this mercury gold amalgam, the vapors are invisible and odorless. So miners, unless they received this training or education from somewhere, you'd have no idea that it was harmful. You can't smell it, you can't see it, and unless you inhale a huge quantity kind of directly under your nostrils, you won't have really severe impacts right away. It's something that kind of builds up over time. And when I was a consultant working with a geological exploration company, I've seen a numerous men and women kind of suffering the chronic effects of mercury exposure, and it's very debilitating and quite horrific to see. And we've done quite a lot of work in Zimbabwe on this issue, where it's regarded as one of the top 20 health issues of the entire population. And some stats from a study there show that most miners have some degree of mercury intoxication, and that over time it reduces an entire population's IQ. And obviously, the closer you are to the amalgam being burnt, the more susceptible you are and the higher the risks to your health. And so almost 10 years ago now, 120 countries or so signed up to the Minamata Convention. Because ASGM is the largest source of man-made mercury emissions, this international treaty was adopted to try to reduce and eliminate mercury use from the sector. And it focuses on three key strategies. One, which is more technical, focusing on better processing and removing some of the worst practices, like adding mercury directly into the milling process, but also on some of the softer issues around formalization and ensuring that miners have a voice and a way to access markets and are legal and supported by host countries. And then a final one, providing more research and data and information on ASM mining and milling practices and how much mercury they use, and so what the optimal conditions are. So going into a bit more detail on some of these challenges and others, it's important to know that there is no quick fix to the mercury problem. Currently, there is an international competition called the Mercury Prize, and somebody in the States is offering $1 million if anybody can find a solution to the mercury problem in the ASM sector. And for decades, there's been lots of different machines, contraptions, potions, different magic fixes, which I've always kind of reviewed with a kind of critical but interested eye. Um, and there simply is no direct replacement for mercury. Um, it's it's kind of magical in what it does and how effective and cheap and easy it is. Um, but that means that this problem of informality, that miners don't have licenses, they don't have access to support and training, and the organizational support, technical and financial assistance, uh, limits their ability to access better equipment for cleaner processing. And so this first challenge around formalization, it requires a kind of continuous and gradual improvement. And another issue is that miners are poor. Although gold mining often pays more than farming and fishing and other livelihoods, many of these miners are still only making $2, $3, or $4 a day. And so even for a small scale mechanized but mercury-free mining millings process, you're looking at upwards of $100,000 for just a small jaw crusher and hammer mill and shaking table, shown in this image here. And so this is why miners use mercury, because you can buy a bottle for $10 or $50, and you can earn that money back by the increased gold you recover. It's very portable, quick, easy, and cheap. And of course, all this equipment, it can be very easily damaged, has to be maintained and repaired. And so to operate this equipment, you need some training, you need access to spare parts, you need working capital, and yeah, miners in Africa and Asia don't have access to working capital. Another issue is the geology and the grade of these deposits. So yeah, every mining geologist and most mining engineers will know this phrase that grade is king. It doesn't matter how large always the deposit is, but higher grades can kind of save you from any other metallurgical problems or other mining issues. And so it's directly related to the feasibility of a deposit. And miners, artisanal miners, have always been known as the quote-unquote barefoot prospectors. And still today, many professional geologists will go onto Google Earth, look at satellite imagery of where artisanal gold miners are exploiting from shallow pits and rivers, and then use that as an exploration indicator to discover large-scale deposits. And some of those deposits pay off and are kind of a major discoveries found. And when that does happen, those artisanal miners are usually kicked off so that an industrial miner can come in. And what this means, over years, is that artisanal miners get pushed onto smaller, discontinuous, patchy, lower grade deposits. They don't have access to the geological and exploration data they need. And even if they did have it, they probably wouldn't know what to do with geochemical or geophysical reports. And so this encourages a lot of risk taking on the behalf of miners, and yeah, results in lower returns. So large-scale miners have a really important role to play in working with the local artisanal miners, and in often cases there's win-win situations of where they can kind of use kind of the existence of artisanal miners either to purchase ore directly from or help in training, and de-risk operations by engaging in a better kind of socially responsible exploration strategy. And another challenge, as I kind of touched upon already, is yeah, the issue of education and awareness. Miners learn how to mine from one another. They don't have formal education normally, and so they kind of just develop the habits that others are using. So delivering training for artisanal miners is really crucial. and especially some awareness around mercury-free processing options and the business decision-making process behind that. Basic mineral economics and feasibility studies to know what it would take to pay off for a $10,000 investment or a $100,000 investment. So this could be several lectures long to talk about the different technical interventions that are available. But what most people think of immediately is PPE and wearing masks. And this is the option of absolute last resort. Much better is to engineer mercury out of the processing solution, but that can be very, very expensive and might not be feasible for all deposits and operations. So other options that are also very cheap and in between are things like fume hoods, which is essentially a chimney that goes over the amalgam burning area, so that instead of the mercury vapors going directly into your respiratory system, they are evacuated higher and farther up into the atmosphere, so they have less impact on your health directly. Or retorts, and retorts capture the mercury within a closed loop system, and the mercury can then be recovered and recycled and used again. But mercury-free processing is still rather simple. There's advanced gravity techniques involving centrifuges and shaking tables. But of course, these pieces of equipment cost $10,000 or $50,000 and require training and maintenance, and larger quantities of ore delivered. So instead of just a little bit of mercury being used for this group here and this group there of 4 miners, producing 100 kilograms of ore per day, you have to organize miners to be able to feed one plant. And so you have to change the mindset about how miners access equipment and share revenues, profits, and losses and risk, and that can be a challenge. So yeah, what does success look like from a technical standpoint? Well, the image on the left is kind of a picture from Zimbabwe demonstrating a mercury-free gold plant. In the very background is a small jaw crusher feeding a Chilean mill, or what's called a wet pan mill. Those 2 large wheels roll around, crushing the ore down to sand and silt sized, and that material is laundered into a gold catcher, or a low G-force centrifuge that spins around, and the gold is captured in those riffles you can see. And that whole system there, including the generator, probably costs around 50,000 USD, which is a low investment, but not insignificant. And then on the right, you see small cyanidation vats, and that is become a huge factor in the move away from mercury, in that cyanidation, which is used by the large-scale sector around the world, is being increasingly adopted by the small-scale sector because it's also very, very simple and very cheap to process. One real pernicious problem is that most of the tailings that are leached with cyanide are tailings that contain residual mercury from earlier mercury amalgamation panning. And mercury and cyanide form a complex that doesn't break down the environment and bioaccumulates and has much more negative impacts than either mercury or cyanide alone, and is very lethal to aquatic environments and has a very negative impact on human health. And here is another operation also in Zimbabwe from kind of a modern milling operation for artisanal mining. Something that you'll note, which is unique in Zimbabwe than any other country in the world, is the existence of stamp mills. Like old Cornish stamp mills for tin mining, these are just large wooden or steel rods with a large weighted steel piston on the bottom that falls down to crush the rocks. Miners prefer them because they can see the whole operation. Um, there's no kind of hidden ball milling kind of black box. And they are rather cheap to acquire and build, and very simple to operate. There's few moving parts, and repairs can be made with very simple tools. So yeah, they're in existence in Zimbabwe, but no other country in the world who've kind of moved on to more modern comminution techniques. But in this process, yeah, there's both stamp mills and a Chilean mill for finer grinding. And then to reduce and eliminate mercury, there's several centrifuges and a controlled panning area so that tailing can be checked. And yeah, better um, mercury-free processes can be used. And here is another setup, similar way, also using these wet pan mills, which are very popular around the world because they're cheap and low energy. They're not the most efficient at grinding, but they're pretty good. Um, and this project is an example from Mongolia, um, where yeah, kind of improved milling and processing methods were used to reduce mercury quite significantly, along with a formalization program to ensure that miners had kind of legal and financial and administrative support. And this facility here with, I think, 3 wet pan mills operating can operate up to 8 tons an hour. And it is, yeah, been kind of regarded as a success in Mongolia, which has a significant ASGM population. Here's an image too from a plant that was just installed recently in Sudan in North Africa. This is like a turnkey, all-in-one ASGM system. Up above on the concrete platform there are a jaw crusher and hammer mill, and the hammer mill then feeds down directly onto the shaking table. In this test, the man is sweeping up some concentrates to test tailings for the presence of gold. And yeah, this 1 ton per hour mercury-free system cost around $70,000 USD. Now, once you have the concentrate that doesn't contain any mercury, you have to still get out the gold button. And so there's yeah, different chemical and pyrometallurgical techniques for doing that, which I won't go into. But there's a lot of interest in direct smelting, so taking the concentrate of gold, which might contain, you know, from 5% gold up to, you know, 50 or 80% gold particles, mixing it with borax and other leachates, and yeah, directly smelting a button for sale without the use of mercury or cyanide or nitric acid. Yeah, as I mentioned once already, cyanidation has been a big change in the sector, and it has grown tremendously across Africa as miners are kind of adopting larger scale operations. They're facing lower grade ore or having to reprocess old tailings, and finding out that you know, mixing up a few bags of sodium cyanide and running it through these tanks with some old tailings or some low grade mine ore, you can recover significant quantities of gold. But as you can see on the bottom right, the environmental and health and safety controls are very much lacking, and there's a real urgent need and crisis to support small operators in safer, healthier, and more efficient cyanidation practices. And yeah, this is just kind of a snapshot. There's a whole range of kind of different technologies to to use, depending on the different size and scale and knowledge of the miners, from just improving the existing sluice boxes that are being used, to investing in either higher throughput or more modern and effective milling processes. So yeah, in the last slide, I just want to kind of open up that there's a lot of career opportunities that you might not think about within your kind of mining and geology career. These are just a snapshot of some of the organizations that work on artisanal and small-scale mining from the development sector or from the kind of international kind of policy sector. There's organizations all around the world that work on this, and yeah, it's worth keeping it open in your mind about your future career and how you can make a difference, not just as a technical specialist, but yeah, improving the lives of people and having a great time doing it. So I hope that you've learned a few basics around the ASM sector and understand that it's a hugely important part of the mining sector, employing 40 million people and contributing to a large proportion of the metals and minerals produced each year. And if you have any questions or comments or thoughts or ideas at all, please get in touch with the email address listed there. Thanks.